Hello and welcome to Add-on. So, the question is find the Fourier transform of a function fx is equal to e raised to the power minus a mod x and a is greater than 0. So, हमें find out करना है Fourier transform of a function fx and इसके लिए हमें definition याद होनी चाहिए, that is Fourier transform of a function fx is given by minus infinity to infinity f of x e raised to the power iota sx dx. And हमें जो फंक्शन गिवन है इट इज e raised to the power minus a mod x. So it is e raised to the power minus a mod x. सबसे पहले हम फंक्शन को सिंप्लीफाई कर लेते हैं which is equal to e raised to the power minus ax when x is greater than 0 and e raised to the power plus ax when x is less than 0. Since mod x क्या होता है? Mod x is x when x is greater than 0 and minus x when x is less than 0. So x less than 0 के लिए ये हो जाएगा minus x and minus minus plus, so e raised to the power plus ax and it is e raised to the power minus ax and a is always greater than 0, so इससे कोई difference नहीं आएगा. So finally fx is this in two intervals. So इसको solve करने के लिए हमें integration को दो parts में divide करना होगा, when x is greater than 0 and when x is less than 0. So उसके लिए we write integration minus infinity to infinity f of x e raised to the power iota sx dx. Break it in from minus infinity to 0 f of x dx plus 0 to infinity f of x dx, and here there is a multiplication by e raised to the power iota sx. So multiply it by e raised to the power iota sx with dx. Here also e raised to the power iota sx dx. Now वैल्यू पुट करेंगे दोनों इंटरवल्स के लिए, जो होती है माइनस इन्फिनिटी टू 0 f of x क्या होता है when x is less than 0, it is e raised to the power ax, that is e raised to the power ax dx plus 0 to infinity again it is minus infinity to 0 f of x के प्लेस पे e raised to the power ax and e raised to the power iota sx as it is भी आएगा plus integration 0 to infinity when x is greater than 0 fx क्या है e raised to the power minus ax e raised to the power iota sx dx. Further simplify करेंगे Fourier transform of a function f of x is equal to minus infinity to 0 e raised to the power a plus iota s x dx plus integration 0 to infinity e raised to the power minus x a minus iota s dx. Now it is e raised to the power a plus iota sx divided by a plus iota s. Limit is from minus infinity to 0 plus it is e raised to the power minus x a minus iota s divided by a minus iota s in minus, limit is from 0 to infinity. Now put the limit, it is for 0 e raised to the power 0 upon a plus is minus e raised to the power minus infinity upon a plus is plus put the limit infinity, it is e raised to the power minus infinity divided by minus a minus is minus e raised to the power minus 0 divided by minus a minus is. Now e raised to the power 0 and e raised to the power minus 0 is 1 and e raised to the power minus infinity is 1 upon e raised to the power infinity is 1 upon infinity is 0. So ये हो जाएगा 1 upon a plus is minus 0 plus 0 minus 1 upon minus a minus is. So ये होगा is equal to 1 upon a plus iota s minus minus plus 1 upon a minus iota s. Now it is a minus iota s plus a plus iota s multiplied by a plus iota s and a minus iota s. There is a division and multiplication of a plus iota s and a minus iota s, जिसमें iota s से iota s cancel That is, Fourier transform of a function fx is equal to 2a divided by a square minus iota s का whole square. Since a minus b, a plus b form is equal to a square minus b square. ये भी a minus b and a plus b की form में. And iota square क्या होता है? Iota square is minus 1. So it is equal to 2a upon a square minus minus 1 s square, which is equal to 2a upon a square plus s square. Hence, this is the final answer for Fourier transform of a function e raised to the power minus a mod x such that a is greater than 0. That is, Fourier transform of e raised to the power minus a mod x is equal to 2a upon a square plus s square. Hence, this is the final answer.